All right. Okay, for the recording, good morning, good evening, guys. Welcome back. Session 10 of the GenAI Engineering. So we will be continuing with the agentic AI. So rather last week we just had an introduction. We struggled a bit with the LangChain because of the library issues. What I got some feedback was some of the people wanted to revisit the concept. So we'll just go back, revisit the concept. It's very plain and simple, nothing to um, be worried about. The only thing is you don't have to look at all the complex things. We start at the basic, the foundation, and then we move forward. Okay. Um, so with that, we'll get started with the agentic AI here. Let me get this. And if you have any questions, please do let me know. We can discuss further here. Okay. All right. So what did we understand from the agents before we get into anybody? Like if you can recall from our last week's conversation before Diwali, if you have still not forgotten after the Diwali parties. So what did we, in anybody, what we talk about, what is an agent at very, very simplistic basic level? What is an agent? What is an AI agent? Come on guys, somebody.
Yeah, agent is like a broker, right? Like it can do some, it can fetch some data from internet. Another agent can bring the data from the calculator. Like you can create a multiple agent that feed the information to the LLM to get the more accurate data.
Okay. That's nice. Yeah, agent can connect and bring data. Okay. What else? What does an agent consist of, basically? What makes up an agent? Components.
Like it will take the input and actually it uses the knowledge that we are going to feed, and based on that one, it will respond to our questions.
Okay. So what is the brain or engine of an agent?
Models, that is
Agent
Okay.
itself is a
Yes.
LLM, right? I think.
Okay, LLM model. Okay. Yeah. So agent is, you can say, a module. Okay. Or a capability, it's to do something, right? So in the simplest terms, you give it a task, the agent will figure out to complete the task. Okay, that goal. What does an agent has? Simple. Say a user has a request. It gives you something called, so you give some a problem statement or a goal or a task, okay, to the agent. So the agent is a wrapper or a module, or you can call a container, which has three parts. So the brain you see there is your model, the LLM. Okay. Now, the agent has some kind of software or the instructions or wrapper that built around to use all of these. What it does is it has a capability to do the planning with the help of the LLM. Okay, so whatever, just think of it. Any task you get, okay, let's say, as I said last week, right? So you have a task of fixing a pipe leak, for example, a plumbing issue, right? So you call a plumber, let's say he's an agent, right? Now, he would come and then you tell him at the high level, hey, there is a water is not coming in some place. So that is the issue. That's the high level goal that you give him. You don't go and explain in this pipe, inside this here, or this is how it is doing, this is what's coming, it's all that. So you just tell him the problem, high level. Now he will do analysis and do the planning. So he will understand, okay, so the top, first floor or second floor in the bathroom, the water is not coming. So what could be the problem? So he has to analyze, right? So is the water coming from the main, or is there a stuck, or the pipe is broken, or whatever? So he can plan that. Okay. So let's say he has based on his experience, right? Based on his knowledge, right? He has been doing the plumbing, he knows, he has knowledge, and then he has experience of fixing those things. So from that knowledge, which is, let's say, our LLM model, he will start planning with LLM what he has, with his experience and knowledge, what he has to do. Then to fix that, he need tools, obviously, right? So what are all the tools that he has to do that job? He will check. Okay, let's say there is some tool he didn't bring, or he does not have a ladder or something where he cannot not reach to a particular place to check, or to go into the attic or something. So which means at that stage he cannot continue, or he cannot complete the task. So he needs that particular tool, right? Then he has to have memory. Memory is mostly like he has to. We take it as a basic for the human beings. Like, we remember what we are doing. First, so let's say he's going step by step. He went to the meter outside the room. He closed the nozzle. Then he came back, and then he checked the lower thing. He remembers. Okay, so this is done. This is not the problem. This is done. This is not the problem. So everything he has to remember, like what he is doing, and then what he needs to do next, right? So if you apply the same nomenclature here, at a very simple, an agent is just a combination of three things: LLM, tools, and memory. That's all. Okay. Now, any agent, any platform that gives you an agent, a container to build an agent, it's like a library, just like a Python library you get, or any language, where or a UI you drag and drop. So it gives you an empty container of an agent, and then you fill up these three things: the model, the tools, and the memory. The model it can use. It can be like OpenAI, Anthropic, any model that you want to use. You give that model to the agent. That will become its brain. Then you give tools. As somebody was saying, it can connect here, it can connect there, it can do this, it can do that. So web is the most popular tool, like to connect to the web and then do some analysis and get back. So there are a lot of tools for web. Basically, it can be like web scraping, or it can be a API with the web that can run. The tools can be anything as well. It can be a web scraping tool. It can be an API. You call an API, get a response. It can be a database connection, like you connect to a database using, say, Python connector or SQL connector, connect to the database, execute SQL, and get back the results. That can be a tool. It can be a RAG. Basically, we built all of the RAGs, right? So one of the tool can be you build the complete RAG and give that as a tool, where internally, if you want to get some document or get some information, get some knowledge, you create that RAG and put that complete RAG application or RAG as a tool and give it to the agent, right? Or you can write your own functions, Python functions, and then make it as a tool, the function itself as a tool for the agent, where it can invoke that function when it needs to do if it needs to do what is there that function can do. So any of these tools can be given to the agent. Again, how an agent uses these tools, okay, is up to its model and planning. That's what it decides, what problem it has. So the planning will split into the smaller tasks, and for each task, the agent planning with the model will decide what tools it has to use, and it can use in a loop until it finishes a task, multiple, and it can keep calling multiple tools for the task. Here, you only give one problem, but the agent internally can split it and call multiple tools to complete the entire task. And as I said, it has memory to uh, understand what tasks it has completed, what tasks are still pending. So until all the tasks are completed, it is satisfied the final goal, the answer, then it will come out of the loop and give you the answer. So that the memory again here, as we talked about, can be short term or long term. Again, short term is simply it's a RAM basically. It is available as long as the agent is running, as long as that application is running in memory temporarily. And once the session is ended, you lose that. Long-term memory is basically if you have run something, if you have processed something, and then you got information, you don't want to do that again next time. You store all of that in a database. It can be a relational database, it can be a vector database. So that next time you can load all of that into the agent's memory as a context, so that it doesn't go back and do all the processing again. Okay, so that is the memory part. So this is the basic architecture of the agent. It's not very complex. It's very, very simple. It looks complex, but it's at the core, it is very simple. Because most of the logic, again, you don't have to do the heavy lifting. The agent will automatically, the platforms, the applications will automatically take care of that.
Harun, I have a question here.
Yeah.
So I understand this three piece, right? But could you explain it or let me see that, if my understanding is right? So when the user makes the first request to the agent, the workflow would be that task would go into the planning piece, right? Where it would be breaking down into multiple tasks, so to speak, right? Those tasks are then loaded in the memory, short term or long term, right? And then depending upon how agent sees it, sequential or parallel, it executes those tasks, and it uses the tool. As it is getting all the information from the tools, right, pertaining to those tasks, it is then accumulating it back, putting it back into the memory, and then at the end, when everything is there, the agent then pulls the needed thing from the memory and brings it back to the user. Is that the right workflow? I mean, there could be many things, but will that be?
Yeah, you're right. Yeah, absolutely. Yeah, that's what
Okay.
at high level that happens. Yes.
Okay. And this memory binding, what you say, like short term and long term, is it something which is programmatically has to be done, or is it something which is more an inbuilt thing of the agent?
It can be. There is some kind of programming that see, internal is fine. You just mention, hey, take care of it, or default is internal. You don't have to worry about that memory part. If you are implementing an external memory store, that caching, that is when you have to do some coding part to it right. You have to create those. Just like vector database, right? You have to create those components. You have to write it to that vector database, and then you have to pull it back from the vector database into the context, and all of that has to be implemented in the long term. But most of the cases, the short term would suffice because it's transactional, right? It's kind of a user request, you respond. Most of the times you don't need that information to be again recalculated for another user. You don't expect. So basically, if you're saying that the same question is being asked, the same task is being given multiple times, in that case, maybe you can. But most of the use cases, the short-term memory would suffice.
Okay, got it. Got it. Thank you.
Okay. Anybody, any other questions about the architecture? Okay. So we have done the vector search applications, right? We have built chatbot, basically the RAG, complete RAG, okay, applications. Now, as we talked about the agentic AI, as we just spoke about. So that is the agent you see, and inside that is the LLM model, that is the brain. So it has a task, it has a task and role. Basically, you give the agent a task and role. Why we are saying a task and role to the agent is there's a multiple agents when you have. So each agent is specifically doing a particular task, a particular piece of the entire problem, and it has a role. Okay, a travel agent does specific to the travel planning. A hotel agent can do tasks specific to searching for hotels or booking hotels. A airline agent can specific task of searching for the cheapest airlines or tickets and booking tickets. So on and so forth. So that kind of a car travel agent may be for hiring a car travel rental cars. Again, all of this, why different? Say, let's say you're planning a vacation, right? That's the entire holistic travel plan. That's a task. Now each agent has to split it and do their own part, but it has to fit into the overall plan again, right? So let's say you're going in for a 7-day vacation and you want rental. The car rental agent has to specifically understand if it is a multi-city, right? So you're maybe if you're going to Europe, you're not going to stay 7 days in the same hotel and same city, right? Now, the car rental agent has to figure out what is the overall itinerary, which city, which days you need car rental, and what are the available rentals in that city for that date, and what type of car you need, and then get all the options. Now, if it goes and say, hey, I'm a car rental agent, my task is just to do car rental, I will go and do 7 days done in the city, or duplicate it in all 3 cities, 7 days, book multiple cars. So that will be chaos, right? So it has to fit into the entire thing. That's where the memory comes in. Like what the planning agent has given you. What is the travel plan? Which city, which days? So that output has to be used by the car rental agent to book the cars in those particular cities for those particular days. Same thing with the hotels. Same thing with the airlines. So the airlines, it has to sync. So the day the flight is landing in that city, the car rental has to be in that city at that time available, right? You get down the flight and then you go and pick up your rental car, right? So that has to be coordinated between these two agents, shared between these two agents in the memory. What is the output? What is the plan? How I'm going to book, right? The same day, the check-in, the hotel has to be done for that particular city. The checkout has to be planned. When the checkout is happening, you have to plan for returning the car rental and also going to the airport based on the time for the departure flight. So all of this has to be orchestrated. So that's a specific example. You will be building and build that as a project. How multi agents can coordinate building, planning out that entire itinerary. Okay, so that is the agent. Each agent will have a task, will have a role, and then to orchestrate all of these agents, there will be a supervisor agent that says, the agents can go parallelly or sequentially, and an agent can do the task by itself, or it can delegate to other agents. Hey, can you do those tasks for me, kind of a thing. So that's the agent. And as I said, you have memory, short-term, long-term. It has a planning. It can do reflection of what it has done and then critique. It will go back and critique its own output. And then if it is not satisfied, it will go back and do another iteration of the same process. Tools, very important. Without the tools, nothing can be done with the agents. Most of the tasks other than the LLMs, which will again be the same thing. So the tools can be a vector search engine, a calculator, a web search, or it can be connecting to your apps, Gmail, Slack, to read your emails or to send an email or to ping, communicate or anything. So that anything can be a tool. And if it is a vector search, you have a vector database with collection or whatever, all of this. Okay. So this solves both of your problems, limitations of an agent of a LLM model. If you just use a LLM model where we said it does not have knowledge of your internal database, which is not publicly available, and personal information, which is solved here with the first, this vector search engine and the RAG part. It does not have access to the current latest what is happening in the world, which is solved by giving them these tools like web search or applications to connect to and all of this. So we're solving both the limitations with this. Of course, there is one more, that is hallucination. That is an ongoing improvement as we go along. We have come a bit far, but not there yet completely, to how to figure out a hallucination part 100%, right? So that's where as I was talking to Neeraj yesterday, that's where the industry is a little skeptical about to adopt completely, embrace completely. But there are many, many use cases that we are benefiting. The industry is benefiting right now. One of it is improving the productivity or adapting the AI itself and improving the productivity, let's say for coding purposes, the code generation models. So we will do one session on code generation and build one application next week with that. So how your productivity is increased from 60, 70% using these code generation models. Okay. The creativity part where it's again 70-80% of productivity improvement is shown in terms of marketing campaigns, ad campaigns, in that research for legal and all of that, summarization of documents, where we were doing one of the project at our workplace to generate a RFP template. Every time a new customer comes in, the standard time is at least 5 days to come up with an RFP question and answers and then build a template. Now, building this AI with RAG, getting in all the existing RFPs they have done earlier, using those documents and preparing a template. Now it has come down to from 5 days to 5 hours. Getting that template. Because it can read all through existing RFPs, pull out the questions, pull out the answers, give it to them as a template. They can just select and keep it, or they can rewrite or overwrite the answers and then generate a template out of it and then work on that. Code generation, yes, again, for any of the data transformation or the data ingestion, data transformation, data aggregation, all of this ETL pipelines, logic in the data platforms, all of that can be generated using the code generation, like in Databricks. You have DBRX inbuilt. In Google Colab, we are using Gemini, which is already embedded, or we can do Anthropic, where we can generate the code and then help us in getting the productivity for building these ETL applications, right? So that's where the entire thing is. I don't want to crew AI into yet. We'll do tomorrow. I just want to come back and work on this part. Okay, the agentic part. Now we'll just go into. Let's go here. So we talked about agents, right? And how agents are implemented. So basically, just like models, every provider is giving you a model. A lot of providers are giving you models, like OpenAI giving you GPT models, Anthropic is giving you Claude, and DeepSeek, Bedrock, Grok, Bedrock Titan models. So all of this, right? Similarly, all these platforms have an implementation of agents. So they also give you a implementation, a library to create agents. Okay. So if we go to LangChain, basically that's where we started with as a platform. Okay. So it has deep agents, LangChain. So if you go here, agents. Okay. So look at this. So this is how an internal agent works, right? So if you have an input, it goes to a model, it has tools, takes an action, tool gives you response. You can see this is a loop here. Okay. This output is again within the agent, it is evaluated. And if it is not satisfied, it can call the same tool again with a different query, rephrase the query, or it can call it. So one task is done, then it might call another tool for the second task. So it goes in this loop, and this is autonomous. You don't need to write any of this stuff. And then when it is done, it will give the finish and it will give the output. So that's what goes on inside it. So you have a model, and then you see here, it gives you libraries called create agent, in which you give a model and then you give the tools. So as I said, memory is default. It will use internal memory if they want to, or if you want external models, external memory also, you can do external memory as well. Okay. You have tools, you can create tools and all of that. Prompts, all of this we have done, right? So at high level, let's say create agent, okay? Production ready agent implementation from LangChain. If you're using a LangChain, you get a create agent you can use to just create an agent, and then you can pass all of this. So model is what it needs, and tools as a sequence, whatever number of tools you give it. And then all of these are optional. System prompt, middleware, response, all of this, state schema, and all of this, it will come back. We'll come back to that. And it already has like cache, agent state if you want to save. So all of those are, we don't want to worry about at this point of time, for the basic foundation part. So using this, let's say I want to do a implementation of an agent. So give it an agent a task. So what I'm using here is the LangChain libraries, LangChain OpenAI, LangChain community, and a particular version of the LangChain just to be compatible. And then we will go ahead and install these libraries. Boilerplate code. Yeah, before we get into this, any questions, anybody else? Everybody's clear? What is agent?
Yep, at the surface level, yes, Haru, I think. But
Yeah.
there's more, right?
Yeah. Anybody else? Gopi, Nitin, Sandeep, Venkat, Hari knows. Yeah.
Yeah, this is clear. So I have just one question. When we are explaining the AstraDB, there also we can create the workflow, right? So in that, do we have an agent option or there is no agent?
Sorry, come again.
When you explain the AstraDB, there we can do a no code.
Blank flow, you mean?
Yeah.
Yeah.
Yeah, there, correct.
Even the no code platforms also has can do the
These agents.
agent. Yes. Yeah. So we have seen the other day actually, right? So there is a menu item called agent, and then you drag and drop, and you fill up these three, what is the model and what are the tools. You connect all the tools to that. We will do the LangFlow also in one of the sessions as a no code. How do you create an agent? How do you connect the tools and all?
Okay.
Yeah. Now we'll put the key here from LangChain core tools again. So I think we did this last week, add and multiply. We are creating two functions, and with the tool annotation, we are making it tools to add two numbers. So I fixed this using the new libraries. So I have created a list of tools here. One is multiply, one is add, chat OpenAI, model is GPT-4o, and then these are the template, chat prompt template, where you have system message, user message, and it's taking an input. Okay. When you execute this, then you build input. So from this, you say create OpenAI tools agent. So this is the library. This is the function where you can give a base language model and tools. So there is a create agent, right? So that is there. That's the latest implementation. So as and when the versions change, the implementation of the functions change. Okay, so there are some dependency issues with the LangChain core memory. So I fall back on the older version to this. That's why I hard coded this 1.1010 version to go back to have the stability. This OpenAI tools agent, as I said, you need three parts: LLM and tools I have given. Prompt is okay. Whatever is the input that you want to give to this, and memory is default here. So you create an executor using this agent, and again the same tools you provide here. And then you go agent executor dot invoke. You are invoking this agent executor, which will execute this agent with this template, and template needs an input, so we are sending an input here. So when you run this, the agent will automatically go and should select that particular tool and then run and give you the information. So for some reason, the tool calls are not shown. We've seen the tool calls last time. This implementation, I think they have removed the tool calls, but this is the overall understanding of how you do the input and output. So basically how to create an agent. So you are not doing anything except use the function and then pass your model and the tools that it can use.
Harun, a quick question here. So my earlier interpretation was that LLM is part of the tools, but you have to specifically mention that, right? It's not, or is it just syntactically different?
LLM is not part of the tools.
Okay.
Okay. So if you look at here, the LLM is here. This is the LLM. It's not specifically mentioned.
Okay.
LLM is one. The model uses the tools, whatever you
Got
give.
it.
So there is a model, there is tools, and then, so this is the part that is not visible to you, but memory, it can be internal or external. You can specifically mention, or by default, it can take. LLM and tools are what you provide mandatory to this.
Okay.
Okay.
And planning is internal. That's something that's
Yeah,
not.
planning is internal completely.
Okay.
How an agent, orchestrates the entire problem solving for you.
And for the agent, at one point of time, it is one-to-one mapping with the LLM, right? It's not that you could give multiple LLMs as part,
Correct.
like.
Yeah. Each agent, you can have only one LLM. However, when you are doing multi-agent system, so each agent will have a model, and you can have different models for each agent.
Got it.
It's not mandatory that same model should be used across all the agents. Each agent will have its own LLM model, and it can be different model for each agent.
Okay.
And of course, tools will also be different. And you can also specify which tools can be used by a particular agent. It's not a pool of tools. You can mention and say, hey, for you, these tools are available. For this agent, these tools are available to use. So you can restrict that usage of tools, or you can provide those tools to the agent. So it can only use the tools available for that to solve the problem. And when it sees there are other agents which has more capabilities or more tools, and there are some tool that it cannot execute or it cannot solve the problem, and if there is a facility or if it has access to delegate that, so it can go and give to the other agent saying that, hey, you do this job because you have the tools, I don't have the tools, I'm delegating this, you do this and give this back, give the output back to me. So that orchestration can also be done.
Okay, got it. Great. Thank you.
Yeah. All right, so that's the LangChain, very simple. How you create an agent, how you get the tools to use it, very basic understanding. So we'll do the same thing called a Agno library. Okay, so Agno is again the same as it's built on the LangChain. It's a framework. Okay, initially it was called PhiData. Now it's called Agno. Okay, so if you go and see Agno framework, okay. So Agno is a multi-agent framework, runtime and control plane built for speed, privacy, and scale. It has, again, agent, multi-agent teams, speed-based workflows, whatever, all of that to, again, create an agentic AI application. It has persistent state, knowledge retrieval, memory, advanced features like human in the loop, guardrails, and MCP support. Okay. Multi-agent teams that operate autonomously under a team leader that maintains shared state and context. Okay, that you can create a team with multi-agent teams as well. Workflows you can create. Okay, so it again is based, as I said, on the LangChain. Okay, and you have a lot of docs can go and refer to what an agent means with respect to the Agno. Okay. Now, if you go back, so I don't have a kind of multiple decks or anything to explain because these are all same libraries or frameworks that you can use to create the agents. So let's go back and see how we create an agent using the Agno framework. First thing we do, we import library Agno, OpenAI. DDGS and Y-Finance are basically your tools. Okay, so in the last example, I have shown you like how we can create a tool using Python add and multiply. So that function basically you can extend to anything. That function you can use to connect to a database. In Python function, you create a Python Snowflake connector or Python SQL Server connector and connect to database, get information, everything you can write in that Python function and use that as a tool. Right? Same thing here. You can do, so these are different libraries, implementations. DuckDuckGo search to search the internet. And Yahoo Finance to do some, it's an API-based implementation from Yahoo that provides this library where you can call this library to get information about any of the stocks from them. Right? So that is the tool. So if you want to do any stock analysis, this is one of the tools you can use with the internet search as well. The first thing, as I said, we import agent from Agno. So let me create this tools. So we create an agent, chat, and we create a search tool from this library. I have OpenAI API key. So we don't have DuckDuckGo tools is free. You don't need any license, any API key or anything. But there are other ones like SerperDev. Okay. Or there is another thing called Tavili Search. So these are again basically third-party tools that have improved and written wrappers around the internet search, web search for the LLMs and for the agentic AI. So SerperDev, I think, is from Google, I guess. SERP API, so Google Search API, yes. So this is one thing you can use, serper.dev, Serper API, just like your DuckDuckGo search, but you can create again same one API key to use with Serper API and then use SERP API to do the web search. Another one is your Tavili, which is popular tool, which goes well with your agent, all your agentic applications. So connect your agent to the web. That's what they specialize. Tavili Search. Okay, these are all the developers using it. This is another thing you can explore and use in the search with the as a search tool with the agents. Okay, so SerperDev is one, Tavili is one where you can go web search. So I'm using DuckDuckGo tools here on this. So OpenAPI key created this tool, and then when I'm creating agent, I'm giving the model. My model is OpenAI Chat GPT-4. The tools, I am giving it only one tool called DuckDuck tool, that is for the web search. Markdown is true. So there are a lot of, if we go here and say, all of these options are there. So most of them are optional. You don't need to provide, but some of them, the first two, even if you don't have tools, it's okay. An agent can just work with the model without the tools, but it will be like just you are calling an LLM, nothing to do with the agent, or agent can only work with the model itself to answer your question. So that is also okay, not to provide any tools, but it will limit the functionality. So you have, you go to agent, and then you will see a model. If you want to name it, ID optional, all of these are optional ones. Session state, you want to write DB session state, enable the agentic state. You want to cache the session. So all of these add dependencies. There will be several options related to the memory that you can explore. Looking for the tool calls. Yeah. So number of history runs, max tool calls from history. These are tools here. See, here is what we are providing, optional sequence of all the tools. Tool call limit, you can set, hey, you can only call the tool this number of times so that it doesn't go into infinite loop, continuously calling the tool and analyzing the output. So all of these, so many of them, markdown is one. You want to put the output in a markdown format or markdown support. It's just for formatting. So there are so many of them, most of them, just like any other standard library, you get a lot of options. You may not explore or use all of them. Okay, so my agent is built now with the model and the tools I have. Okay. What's this again? Where do I need this? OpenAI API key. I already have this. Don't need it. Okay. Now I have an image. Okay. So this image is the URL. Okay. Now I'm giving an URL to the agent. So this is the image of a church. Okay. So there is no text. I'm just giving the image to the model here. And I'm asking a question. Tell me about the image at this URL. Whatever you see at this URL, what is the image you see? Tell me about this image and give me the latest news about it. So this is the problem statement. Okay. So can anybody say how, when I do, what are the possible tasks that I can break this up into? So this is the statement. Tell me about the image at this URL and give me the latest news about it. How do I break? How can I search in general? Can I break it into tasks, or is it one task? What do you think?
It will use the internet tool to get the image, and then LLM will analyze the image and provide the required information, right? Based on the questions.
Mm-hmm. Yes. Is that it? Okay. So about the image at this URL, you're getting information from here to get the image information. And I'm also asking to get the latest news about that, whatever is there in the image, right? So these are two parts. The first one is getting the information about the image. The second part is getting the latest news about that image. Okay. Stream true. So when I run this, tell me about the image at this URL. See, that's the only part it's going. Okay, sorry. Here, the first thing is about the image. It start processing. The image depicts the Church of the Assumption of Blessed Virgin Mary, St. Mary's Church, Basilica is what it is. Where it is, church is one of Krakow's most famous landmarks. And then it can also say, gives you the page where you can go and visit this. Yeah, so it gave me this page, Virgin Mary Krakow, Roman Catholic Parish Church. Okay, so it gave, you can go and cross-check your information about that here. Now, the next part is the latest news about St. Mary's Church. This news alert, so you can go and cross-check here. So this is the news about that church. They found a scorpion, whatever in that language has this. Okay. And there are more news here. So whatever, I mean, basically, it can get the information about the image and about all of this. So these are the two tasks, right? The first task is to understand about the image and get information about the image. And then the second task is, once you know what that image is about, go and get what are the latest news about that image using the web search. So basically here we have only given one tool to do both. So it has done the Wikipedia. So since it is on the Wikipedia, the image, so it went to that image URL, and then it also got Wikipedia information, and it again used the same web search tool to get the news alert about this. So this is basically an example of how an agent will orchestrate, split the tasks and take it one by one based on available tools and the model.
Harun, I have a clarification that I need here. Hello?
Yeah, tell me.
Okay, good. So for the simplistic, I understood, but let's say that if it is pertaining to, any enterprise use case, then I believe at the first stage when there is a query that you had, right? It will first be embedding, right? The splitting the embedding, and then it will take those data and then go into your RAG, and from there, or
No.
earlier,
See,
right? Going to the LLM.
don't get confused with RAG and agents, right? So it is not mandatory to have a RAG within the agent at all. So we built the complete agent application for our project, which is a lead enhancement without any RAG. There is no RAG. We built a multi-agent architecture with Crew AI, about 5 or 6 agents. And each agent has a specific task. One agent to connect to Snowflake database. There is no RAG, there is no embeddings, there is no embedding model, anything. Plain Snowflake tables. It go and runs queries for that particular user email, get the information from different tables, one agent. Another agent is to go and get his customer preferences using an internal API within the internal. One agent is to scrape web with the email to go and get LinkedIn information using the email. One agent is to summarize the comments of the user, whatever he has put in the form. He submitted a form, in that he has put some text in the message. So to analyze that message and give some insights from the message, right? So another data sets, multiple data sets information. One is about his preferences, consent preferences. What are his, did he consent to send emails? Did he consent to marketing material or all of that? So we built this with multiple agents and one summarizer agent to consolidate all the information and provide it. But nowhere there is a RAG in that. So RAG is not kind of a mandatory or a solution for all. Okay, it depends on the use case. If it needs a RAG, yes, you build a RAG. If it doesn't need, you don't need. It's optional. Okay, so that you have to understand, right? Even in enterprises, it's not always required to build to have a RAG. Even we talked about so the other use case where I talked about building a template, it has all the PDF, hundreds of PDF documents where you want to get question and answers. So there is a use case for RAG. Okay, does that answer your question?
Yeah. I think I got it. I got disconnected, but I think I understood. Okay.
Okay, great. All right. Yeah, any other questions, guys? Do we understand what agent is about?
Harun, one basic question. LLM also will have the details about this particular image. Let's say they might have trained till 2021 or something. How come we know that one first it is going to LLM or that it's directly going to web search?
That's a good question. You can check in the tracing what the model is doing. So when we go to the tracing, we do the tracing what the model is doing. That's one way of checking it. The tool calls. What are the tool calls that are happening? Yesterday we looked at, right, last session. That is now in the latest version removed. That there is in the output, the telemetry will tell you what tool calls have happened. Generally, if there is anything about the web and it has a web tool, it will automatically use the web tool. Unless you override and say hey, don't use the web search, just use your internal knowledge. If there is a resource, it will try to use the resource just to make sure it is all correct. But for you, it doesn't matter, right? As long as you are getting the information, whether it is giving from its own or whether it is going to web, because you've already given access to the web tool. If you haven't given the access to web tool, then it will use from its own knowledge. But if you given wikipedia.org, how would it know what image is there at this URL? It has to go and first figure out that, right? The knowledge it may have knowledge about that church, but it doesn't know what you are referring to. This URL can be anything, right? So
Right.
first it has to check in that URL what the image is, and then it will compare with its existing knowledge, or it will go to other web sources to understand about that image or metadata about that image.
Mhm.
Okay. Now, so we have looked at this one tool for the agent. Now let's say I want to do a agent with multiple tools. So again, in this use case, same agent I have DuckDuckGo search tool and Yahoo Finance tool as well. Same thing, I can give a name. Just I'm doing a web agent. There are two agents here, and then I'm doing a finance agent. So this is a multiple agents, and then we are doing a team for this agents. Okay. Agent team. Something. Something is okay. Name, role, model, tools, instructions. Give stuff. So you have this agent team, which is an agent here. So basically, how you want to use the agent with DuckDuckGo tools to do search the web for information. This is the agent GPT-4, and you're using DuckDuckGo tool, and you say instructions always include sources, and then there is a markdown is true. This is web agent. The finance agent you want to use. This is how you create a finance agent, financial data. For this, you give the Yahoo Finance tool. Here you give the DuckDuck search tool, and this is the Yahoo Finance tool. Use tables to display data, and then here the agent. And this. Okay. Yeah, I think this was missing. Let me go back and fix
So
this.
the finance information is available in the DuckDuckGo tool as well, right? And in the internet also. The same information available in finance agent, Yahoo agent. So how do you know which one is the preference here?
Come again, Rupi.
See, the finance information available in the internet that can get it from the
Mhm.
DuckDuckGo tool. The
Yeah.
same information or similar information available in the Yahoo Finance as well, right?
Yes, yes.
So what basis it selects which one is the preference, whether it should go to internet or it should go to finance agent, or it will go to the both and then
Yeah, it
filter
is.
the
It
data.
is. Yeah. So that's where the intelligence comes into play. The autonomous, right? So the model will the planning, right? In the planning stage, the model will decide which tool to use. whether it is generic information, can it go to web agent, or if there is a specific tool that it can use. See here, we have mentioned search the web for information, and here we have not, in the role we mentioned financial data. Okay, so the moment that agent team sees anything about the financial data, it will invoke this agent rather than this agent because of the role that we are giving it. So in a specific role, that's what we said. If it is if I put a booking agent, the booking agent can book either flights or hotels or rental or anything. But if I specifically say car rental booking agent, then we are more specifying the fine-grained role for that agent, very specific role that we are giving. So it will only focus on doing that kind of jobs. So same thing here, we put the general search web for this role, web agent. The role is just search the web for information. And then here we have the financial data. Again, you can also put that instructions here in the, so there is some instructions, right? So you can, if you want, you can overwrite its default planning. Then you can say, hey, for any financial related information, just use the finance agent. Okay, don't use web search agent, or use just the web search agent for everything. So you can mention override some instructions as a system prompt to this. Okay.
Yeah, but in our case, it will search. It will go to the both the agent, or it will go for only the finance agent.
It will go to both.
Both.
Because so summarize the analyst recommendations for latest news for NVIDIA. Okay. Now the latest news, it will go to the web, and analyst recommendations to get some information about this stock NVIDIA, it will go to the this part. Yeah.
Gotcha.
Okay, it will go to the Yahoo Finance. Now, I created an agent team, basically, or in the crew, you call a crew or a supervisor or whatever. That is again an agent, which we provide our all other agents to this supervisor. Web agent, finance agent, and then it will have a model. So this model is supervisor is what it will decide which agent to call. And if the agent has multiple tools, that model will decide which tool to call. Okay. So if we just, what happened? Again, this libraries is changed. That's the telemetry. Where is telemetry?
Is it tools or agents?
This is running the agent. So it is getting
the variable
latest
name
data.
is, yeah, sorry. Go ahead.
Yeah, 1 second. I think it's getting the latest data, 2023 from the analyst recommendations. Okay. And then it is also getting the latest news for that. And these are the sources that it has got from. It has used all the web, Yahoo Finance, CNBC, Bloomberg, NVIDIA Investor, all of that. But see. Does not have ad agents.
The add tools, right, Sayed? It's not a. add agent.
No, the tools are already added here within the agent. Okay, here.
Okay. Oh, got it.
Now, we are building a supervisor agent which will orchestrate and call all other agents. So we have to provide all the agents that are available to this agent. If it's not this, let me see here. If we go to Agno, agent, tools, okay, let's say we, for now, we don't use the theme because I think they have moved this theme from here. If I just go and give both the tools here to the same agent, okay, and rerun this. Okay, now the output is different. So it has both the tools, analyst recommendations, and latest news. Broader context of NVIDIA standing in the stock market, spotlighting its role within the AI and semiconductor industries. So it's basically now using, we have given both the tools. So it goes and uses both Yahoo Finance and DuckDuckGo tool. So we cannot see the tool call here, but we can do let's see if it does the stream. Yeah, so it's giving that information, but we're not able to see the tracing of which tool it is exactly using. Might be in the telemetry, in the tracing, you can figure out. So we'll do the tracing calls also. How do you do the tracing of the LLM? What is happening? At that time, we can check what is happening to the tool calls. Okay. But this is at the high level what an agent does. Okay, it has tools, it has a model, and then using these resources, it can split the task and then run the task using the tools and give you the information. So when we explore more platforms, let's say Crew AI, we can clearly see what is the supervisor agent, what is the normal agents, and how we can add all of these agents to a multi-agent system. So for now, I just want to keep it single agent with tools that it can use. Okay. Any other question you want to use?
Just a high level question, Sayed. So we have one agent with the multiple tools. Also, we have a multiple agents controlling by master agent. Okay. So what's the difference? Why we can't have a one agent with all the tools? Why we need to go for a multi-agent?
Let's see, when you're building an application, we have come with, we know the OOPS concepts. We have modularity built in, right? So you can just write a 10,000 lines of code to do the entire application in a sequence. But you create classes, functions, right? This to have a specific modularity and OOPS concepts, right? The same thing agents basically we need to segregate by their function. As I was saying again and again, each agent will only have a specific role. In the earlier example, I was doing the travel agent, right? You can continuously give all the tools to one agent and give, hey, figure out the travel plan. Or you can have rather each agent do a particular task. It will be overwhelming for one agent or one model to do all of that stuff. Remember, redo all the multiple tasks. So for simplicity, you break it down, the task into simpler terms so that each agent can do a good job of doing the smaller part of the entire task rather than one model, one agent doing all the tasks, right? Or using all the tools. It's just heavy lifting for one model. So to have modularity, to have a fine-grained segregation of tasks, we create multi-agent systems. And again, one agent can have access to only, say, a RAG. He'll only give access to RAG to only one agent or using that tool. So all other agents, the agent should not have access to other tools or other information within the system. So in that case, to make sure each agent has a specific role, task, and only the tools needed to that agent will be given.
Right. The cost perspective, the multi-agent is a better option, or it's a single agent is a better option, cost perspective?
Yeah, one second. So it's not a function. You can think of it as a module. Okay, or a class. Functions you can think of as a tools. Okay. Sorry, come again. What's the question?
The cost perspective, like if you're using
Cost
single
perspective,
agent to
right?
perform
See,
multiple.
No, I think cost will be same, irrespective of 4 agents calling 4 individual calls or one agent doing 4 calls. End of the day, the cost will be on the number of tokens. So each time there is a call to LLM, it will be the number of tokens that will be counted. Even if you use the same model from 10 places, and each time you call one call, or you just use one place and use 10 calls, it's the same thing, right? So end of the day, your cost is not on how many times you use the model. Your cost is how many calls you make and how many tokens you send and how many tokens you receive.
Got it. Then in that case, multi-agent is the better option.
Correct. Yeah.
I think
You will
Harun,
have more modularity in the multi-agent system because you can control. See, again, now we are doing this lead enhancement, right? So what we are doing is we keep adding more agents as we get more data sources. So each data source comes with its own access to a particular role. So we add a new agent so that we don't have to redo the entire application. So modularity comes in place. I don't go and change anything in the existing agents. I just create a new agent and add the agent and go and add it to the supervisor. That's it. So everything else is in the framework will be taken care of.
Oh, thanks.
Harun,
So it comes for us like onboarding a new data source will become just like adding a new agent in the framework.
So maybe if I can share my example here, Arun,
Yeah, Girish, welcome.
Yeah, I work for SAP, and as you know, the ERP, software, you have many modules, right? So within the module, you have many sub-modules. Okay, but I will take an example here. The way we kind of, did this, like you have a sales, you have purchasing, and you have supply chain, right? So these three agents are governed by a supervisory agent. Okay, and that supervisory agent is what we call as an intake agent. Okay, so this agent within purchasing has a specific task to do. Okay, and sales it has specific task to do, and also the supply chain, it has a specific task, right? So and that's how we have kind of configured this. Of course, not exactly the way I kind of described it, but within purchasing, you have many modules, right? So each of those modules, we have an AI agent, and that is talking to another agent. So that becomes a multi-agent. And then he passes that data, or he is empowering the end user with some information or taking some action. Okay. And this is all governed by one supervisory agent. I don't know if that made sense.
Yeah, that's what it is, right? So we have multiple agents, each specific to a module or each specific to a task that it can take care of and has access to, basically, that particular one. So you can control the access as well as the functionality. And then tomorrow, see again how we're doing is we started with LinkedIn, right? And at some point, we found it's taking a longer time and we are not getting proper results because the email does not match the work email or the personal email. So and then you have multiple hits, and then some are profiles are not public. So it's taking long time in the iteration, multiple tool calls and all of that. So we decided to switch off. So in that case, what all we had to do was take the agent offline with just a flag. We created in the environment variable, say LinkedIn agent flag true false. So we just make it false. That's it. We don't have to do anything in the application, and we can control it with configuration. That entire part of the agent, the tools to connect to LinkedIn, get process, everything is switched off. So that's how you get the modularity with multiple agents. So whenever we figure out, there is a data set that you can use instead of scraping the LinkedIn, or when we buy the LinkedIn API itself, you can switch it on again and then get it, right? So you don't have to go back and remove that agent from the tool, remove the tools and remove functionality from if you use single agent.
Yeah, and maybe one last comment I can add there is, Arun, it also made it less complicated for us, right?
Yeah.
So the org data, the users, the data itself, that we use for, say purchasing versus supply chain versus sales versus finance is different. So when we are configuring it, when we are feeding the fuel to it, like for example, the local data versus inherent intelligence of the agent, it becomes much more easier for us to manage that agent than if that agent was one agent versus a multi-agent scenario.
Yep, exactly. Yeah. Okay.
So maybe
Yeah.
my understanding in here, right, is that for simple cases, of course, it does not make sense, right? But the we talked about the cost, right? It's not just the infrastructure cost. You also have to look into things like the speed and the latency, right? So if you have just one agent, your ability to use parallelism is greatly reduced, right? But if you have multi-agent, then things can work parallelism, right? In parallel. And the other thing is like what Felix was mentioning, right? In SAP, or even if it is not SAP, if it is like non-SAP, when you have something like code generation, right? So you could have an agent for code generation, you could have an agent for research work, right? And each agent, as far as I understood, they could be fine-tuned, or they could be, via prompts to do this specific thing. Now, if you put all the thing in one agent and have all the prompts in that one agent, then it will lead to like prompts becoming bloated.
Yeah,
and
right.
then to fine tune when there is separate teams working on it, distributed teams working on it, then it's very hard, right? You fix one prompt and it will break something else, right? That's why I think you would go for this multi-agent. That as simple as that I can think of, right?
Yeah, absolutely. Because one thing is you can introduce parallelism. Otherwise, you can also control that, having sequential or parallel or dependency within the agents. That's one thing, that is flexibility that you will have. The other thing you mentioned, yes, the code generation if you have. So if you have one agent, you are restricted to use one model. If you have multiple agents, as I said, each agent can have a different model. You need not have the same model. Again, as I said, it is charged based on the tokens. So let's say something like you have one agent just to summarize everything. So you don't need a huge model like GPT-5 or Claude Sonnet, where it is priced high, you can use a smaller model. Whereas if you need a code generation, it does not help. So you need to use specific code generation models. So Claude Sonnet 4.5. So you can use just for code generation. So that agent can be different, so that you don't use that huge model for everything, right? One model for all. So you will get that flexibility also to choose for each task what kind of model that I need, what kind of tools that I need. So that flexibility is available. And of course, each agent can be in sequence, or you can configure in parallel. So that improves the processing time as well. This is nothing new. It's just
Yeah, yeah.
like we have been doing for decades. Same modularization framework and including parallelism, OOPS concepts, and all of that. So same concepts, different implementation. That's it.
Yeah, you're right. It's somewhat, strange that we still fall back to the same understanding, right? That why do we need oops, right? I was
Yes.
thinking the same thing. What do you need, Okay.
Yeah, it helps when you relate to what we already know. Right. Yeah. But these are all good questions, right? At least we get to discuss, clarify things. Everybody. Yeah. I appreciate asking questions. It's not, it helps us to clear our understanding for everybody. Okay. So, all right. I think we are at time. So tomorrow we will continue our agents. Tomorrow we will explore more framework, and we will do multi-agents again tomorrow, and see how each agent does a specific task out of it. I'll introduce another platform called CrewAI tomorrow, which is very popular. So we will use that to build some use cases with CrewAI. Then we will go into the no-code LangFlow. How do we build the same agentic application in the no-code platform, AstraDB and LangFlow tomorrow. So if we may not do RAG tool tomorrow, but we will try to cover these two frameworks. And if there is anything, we'll come back next week and revisit, revise all of the frameworks one more time before we move on.
One quick question in here. We're talking about line graph, CrewAI and all. There are different frameworks. Now, LLM providers themselves, like Anthropic and OpenAI, they came up with their own framework. Are they different, or they are just different flavor, but more tied to their platforms?
Yeah, there is nothing different. See, implementation is different, right? It's all under the hood how it would work and what additional features or how robust it is. You would think if I'm using OpenAI, let's stick to the platform and use AgentKit from OpenAI rather than build my own and then port it onto the platform. If you're using Azure OpenAI is already there. So why not just explore what is already available within the Azure OpenAI rather than go to LangFlow and have a separate cloud and then put it on an endpoint and refer that endpoint within my Azure, right? So it's ease of implementation when you have everything available in the same platform versus getting a new thing. But end of the day, same thing, same agent, same model, same tools, everything. It's the way how you do. So if you look at the agent kit from OpenAI, it's more like N8N, right? So workflow, agent workflow, automation workflow using agents. It's the same thing they have tried to replicate within the OpenAI platform. I would personally think, again, it's my personal opinion, I don't appreciate OpenAI doing that because it dilutes when you want to do everything by yourself. Your focus is on generating the world-class, best-in-the-class models. That's a niche area. When smaller players are using it to develop applications, and then you want to do that, you want to do this, you want to do everything, it kind of dilutes. And then the entire ecosystem will not flourish. because you want to do everything. There is nothing left for everybody else. So end of the day, you are doing everything and you're the only one left. So it's not good for the ecosystem. So everybody, I think, should focus on their strengths, on what they do best.
I agree.
Right. So, I mean, again, that's my personal opinion. It's not anything against OpenAI or anything against.
No, I agree with too. Same with the Vibe platforms, right? They're also getting into Vibe coding, and I'm like, why did you get into that? But okay, it's a business decision, right? So.
Correct. Yeah. So I mean, if you have hyperscalers, their strength is processing. It started with processing, then kind of providing the processing platform data. Now they want to do data, they want to do machine learning, they want to do AI, they want to do platforms. Any platform, everything in the same platform. So it's evolution, I understand. But yeah, Databricks is a data platform. They are not a hyperscaler, right? So Databricks uses any of these three platforms, or Snowflake for that matter. So that's why they are unique. They specialize on processing, data analytics, now ML and AI, of course. Snowflake was more like data warehouse, and now they got started implementing getting into each other's space. Databricks got into data warehousing, Snowflake got into data processing, data analytics, both of them into AI with Cortex and all of that. So it's kind of everybody trying to do everything. So yeah, long story short, yes, it's OpenAI's agent kit. End of the day, you look at it, it will also have the same agent. It will also have same three components: a model, a memory, and tools that you can add, more like click and add. And of course, they have that MCP support where you can add tools with MCP kind of a thing, MCP servers that are available. That also we'll discuss in the coming sessions. Okay. All right, guys. Thank you so much. Appreciate it. I will post the recording and notebooks. We will consolidate everything together more, explore more agents, more frameworks. And next week, we will revisit everything and wrap up before we move on to other stuff. Okay?
Thank you. Thanks, everyone. Thank you, everyone.
Next week is the last week?
Sorry?
Next week is ending the outcourse?
No. We have more sessions.
Oh, okay.
We have MCP, we have vibe coding, we have these deployment, we have LLM ops like deployment and monitoring and evaluation.
Okay.
We have a lot of topics to cover. Don't worry. Still have a lot of things to cover. Okay. All right, guys. Ciao. Take care.
Thank you. Bye-bye.
Thank you. Bye.